All right, so now we're at kind of the third section of our module for this week, and we're going to be talking about validity and reliability. So first we want to talk about measurement error. So measurement error is the amount of error or kind of room for improvement that there might be with a measure. This could be due to human error, it could be due to statistical problems. So let's say regarding validity and reliability, let's say that we are looking at a construct, for example, malingering. So this is something we encounter a lot in forensic psychology. Malingering is basically the feigning of psychiatric or medical symptoms for secondary gain, such as to receive disability benefits or to be found incompetent to stand trial. Let's say that we want to develop a measure to assess whether someone is malingering psychiatric symptoms. How would we know if our measure is accurately measuring what we want it to? And then how do we know if our measure consistently measures what we think it's measuring? So if we were to give the measure to 20 different people, how would we know that that measure is going to consistently, the score is going to be consistent amongst all of those individuals? And because psychology and social science seeks to measure constructs that we can't observe directly, so malingering, we can't get into people's heads and know if they're feigning symptoms. There's going to be some degree of measurement error, so we're not always going to get it right. So I want to talk first about reliability. So when we think about reliability, we're really talking about consistency. And if we look at this image, if you look all the way to the left, that bullseye target, the person is hitting it reliably incorrect. So although they're consistent and they're reliable, they're not hitting the target. So this would be an example of good reliability, but poor validity. So with reliability, there's different ways that we can measure different types of reliability, which we'll get into. But one thing I wanted to kind of show you is this idea of coefficients. So when we look at coefficients, we're looking at from 0 to 1. So the higher the coefficient, so 0.9, the better the reliability is. So above 0.9 would be considered excellent. Less than 0.59 would be considered unacceptable reliability. So there's no consistency. And then there's everywhere kind of in the middle. And these are relatively well accepted kind of intervals for what we consider to be unacceptable, poor, questionable, acceptable, good, and excellent types of reliability or amounts of reliability. So just a hint, this will be on the quiz as well, but it kind of gives you an idea about when you're reading these studies and you see, let's say they're talking about inter-rater reliability, you see one of these coefficients, that's kind of what it means. So let's talk about test-retest reliability. So this is a measure of the consistency of data collected at different points in time. So this would be, for example, if we tested the same person using the same measure every 2 weeks, would they get the same score? Or how consistent would their performances be across time? In split half reliability, this is a measure of the consistency of data across subgroups when the data from a test or other measuring instrument are broken down into smaller segments. This can be more efficient than other measures of reliability, so there's no need to give a test to the same person multiple times. This is computed using statistics software usually. So if you go on to do research, you might use Excel, or SPSS is another big one. But essentially, the computer calculates this for you and then gives you a coefficient, as we see here, a Cronbach's alpha coefficient. With inter-rater reliability, this is a measure of the consistency of observations of a single situation made by different people. So for example, if there were 5 researchers who watched the same clinical interview and score a tool to assess various aspects of the interview. So let's say, for example, they're looking at rapport between the interviewer and the interviewee. The scored tools would then be compared to see if all 5 researchers were consistent in their scoring. So are different people who are using the instrument getting the same score? So we wouldn't want to have a measure, let's say a measure of malingering, like we were talking about earlier, where if I scored it, my scores would be completely different than your scores for the same person at the same, with the same type of conditions. That wouldn't be good because that would be not an accurate representation of the person's performance. All right, so let's talk about validity. So thinking about validity, again, looking at this visual, if we look all the way to the right, we can think of validity as being hitting on target. So it's accurate. So it's always, hitting the mark. It's measuring what we want it to measure, for example. And validity describes the accuracy of quality of the data. And it's not an all or nothing. So we'll talk about that some measures might have really good internal validity and some might have very poor external validity. Usually there's strengths and weaknesses. There's no perfect research design and there's no perfect measure. So construct validity is a type of validity. And this is how accurate a measure is at measuring a certain construct. So we can take, for example, the Beck Depression Inventory. This is a measure of depression. And so this is a measure that does have good construct validity. So we know that it can differentiate people with depression from people without depression. It might also help us characterize or categorize people with mild depressive symptoms versus more severe depressive symptoms. With convergent and divergent validity, this is how we can determine validity by comparing our measure with another measure that is similar. So with convergent validity, we can determine validity by comparing the scores on a measure with another one that measures the same construct. And then with divergent validity, we're going to compare a measure that we have to a different measure with an opposite construct. So if we were studying depression, maybe we would want to look at a scale that measures happiness. And if the scores are very different, that would be good divergent validity. With internal validity, this is the degree to which an experiment is designed so that a causal relationship between the independent and dependent variable is demonstrated without interference by extraneous variables. So that's a lot of words to say. Is the research accurately showing you a relationship that's there without, is it explained by other variables that we're not measuring or we're not looking at? So if we're conducting research in a lab that's a very controlled setting, it's going to have the same temperature, it's going to have the same, office or building characteristics. It's probably going to have the same kind of feel for each participant that comes into the lab. That's probably going to have really good internal validity because there's not a lot of other extraneous or extra conditions that are going to vary. The temperature is probably not going to vary very much. The experience of the participant that's there, how they feel when they're in the laboratory, probably not going to be too different from another participant. With external validity, we're looking at how generalizable are the findings of this research to other populations or other situations beyond those in a current study. So if, again, using a lab example, it's not going to be very generalizable if we're conducting research only in a lab where we're controlling a lot of things. If we compare that to people out in the real world, living their own lives, there's going to be a lot of other variables that are not accounted for. And so it's difficult to measure those or really know what they are if we're doing research with high internal validity in a lab setting, for example. So another example would be using a convenient sample of patients from a specific clinic. This will pose a threat to external validity because it's unlikely that we can generalize that information that we learn about those participants to the overall population. Then we have statistical conclusions validity. And this is really looking at whether the conclusions are valid based on the appropriateness of the statistics that are used. So a couple of examples that we've looked at or kind of touched upon before is if there's a small sample size in a research study, was that accounted for in the way that the data was analyzed? Did the researchers look at effect size, which we'll talk about in the coming weeks? Or were they saying that, the findings of this small sample are applicable to the larger population? Probably unlikely. Were there limitations to the procedures that were used because of the type of data? So we'll talk about parametric versus non-parametric data, but different statistical equations and methods have to be used depending on the type and the quality of data as well. So this would also impact validity. So thinking about your hypothetical research now, how would you go about measuring your constructs? So we've talked about that, picking, operationalizing your constructs and then picking measures that exist. Are the measures that you pick, are they valid and are they reliable? So we have some more insight now into what to look at in a research study, looking at different measurements to determine if they're valid or reliable. How would you account for any limitations of the tools that you use? And what would be some possible threats to validity? So for example, other possible explanations for your conclusions. What would be any threats to generalizability of what you find? So just some things to think about. There's a video that's also posted to the module talking about I think it's the 4 different types of validity that this specific teacher goes through, but provides some really great examples and very entertaining. So definitely check that out. And that concludes our lectures for this week. So again, you'll have a quiz this week, and then you'll have your sources worksheet that will be due. And again, I'm available if you have any questions, if you want to talk through topics or how you might define your different variables for your hypothetical research introduction. Let me know. I'm here available by email or office hours as well. So, all right, take care. Thanks, everyone.